Everyone, let's begin Kruskal-Wallis test using Python. So first of all, we would understand where we are going to apply Kruskal-Wallis test. Because when we are testing more than two groups, we are comparing, right, more than two groups, population median of all these three groups. So ultimately, we are going to apply Kruskal-Wallis test. Because when ANOVA is violating assumptions of ANOVA, so then we are going to apply Kruskal-Wallis test. Because when our data is non-parametric, then we are going to apply Kruskal-Wallis test. So Kruskal-Wallis test is used to determine whether or not there is a statistically significant difference between the median of three or more independent variables. And this test is the non-parametric. This test is non-parametric, equivalent to the one-way ANOVA, and is typically used when the normality assumption is violated because normality is not there. So just because of this, we are using Kruskal-Wallis test. The Kruskal-Wallis test by rank Kruskal-Wallis H test, named after the William Kruskal and W. Allen Wallis. On the name of these two statisticians, this name has been given Kruskal-Wallis test. And one-way ANOVA or rank is a non-parametric statistical test for testing whether sample originate from the same distribution. We just want to check because this one is the one-way ANOVA or rank is a non-parametric statistical test for testing whether the sample originate from the same distribution. So it is used for comparing two or more independent sample of equal or different sample sizes. So it extends Mann-Whitney U test. It is an extension of Mann-Whitney U test which is used for comparing only for two groups. That is the Mann-Whitney test. It is a replacement of t-test because when the R data is normally distributed, we are going to apply t-test. When data is not normally distributed, we are going to apply Mann-Whitney U test. So the parametric equivalent of the Kruskal-Wallis test is the one-way analysis of variance, ANOVA. What are the assumptions of this test? Number one is each sample is not normally distributed data. So then we are going to apply Kruskal-Wallis. The selection of the sample is independent of each other group. That means this is not the replacement of dependent t-test. It is the replacement of independent t-test. And these groups should not be related to each other. Independent, when we are talk about those two tests I had already shared in the Python playlist, that is I had already shared, this one is Mann-Whitney U test. And this one is the third violation. Third assumption is data is ordinary data that can be ranked. Data ordinary, or we can say continuous data also, that can be ranked. So hypothesis, in this case, what we are taking, there are two hypotheses. I'm just reflecting these two hypotheses. Number one is null hypothesis is we have taken training A, B, and C are equally effective. Population median of all the trainings are equal. And alternate hypothesis we have taken, this one is the training A, B, and C. Three groups are effective. Right. So here is population median of all the trainings are not equal. Means these are not effective. So I just want to share with you that is the one more important thing. Let me show you one of our, this one is the also, I'm just sharing this case also. I just want to share. Let me open one of my file because this one is the Kruskal-Wallis test. I just want to share what case we are referring. So Kruskal-Wallis test that allow possible difference between two or more groups to be examined and is equivalent to one-way ANOVA between the groups. So what case study we are going to taking into our consideration? The Vice President Sales has developed 3 new training programs for increasing sales effectiveness. There are 60 new hires in an organization. He has randomly chosen 20 people for each training program. After 1 year, he decided to see the results due to violations of one-way ANOVA assumptions. So that is why we are applying Kruskal-Wallis test. And this is the serial number. You could see here total are 60 total sample size, right? 60. And 1, 2, and 3, these are the training programs. This one is the these people, first 20 they had given training program 1, next 20 training program 2, and last 20 is training program 3. And this is the sale in lakhs. You can see here, this is the sale in lakhs, right? So, and these are the two assumptions. Training A, B, C are equally effective. Population median of all the trainings are equal. And alternate hypothesis, training A, B, C are not equal, not equally effective. Population median of all the trainings are not equal. So you can see here, these tests I have taken from SPSS. These tests through SPSS I have generated. And we would like to validate all these tests with the help of this Python. So whether we are in the right direction or all tests are correct. So this is my interpretation. And I just want to show you this. These are my interpretation. And my interpretation is the chi-square value, that is the degree of freedom 2 and 60. P-value, when it is the less than, indicates that the sales differ significantly across 3 training programs. The second training program delivers maximum good results, and it's followed by third training program. First training program delivers the least favorable result. And assumption, this one is my p-value is less than 0.05. That is why it is now. Now we come to this one is the import. First of all, what we have to do to run Kruskal-Wallis test, import scipy.stats.as stats. We will import this and simply we would write this and we would run. Then further is we are going to import C-bond as SNS if you require, because I'm not using any data from C-bond as SNS. So not required, right? If you are using any, this one is the data file, so you can use. Import pandas as PD. Yes, of course, I require this. And import numpy as NP. I do not require. That is why I had put it hash sign. So now this is the one of the important Excel file that I had created. The same data I'm using. This one is in the Word document. This the same data, all the 60 employees data, and where is the training programs 1, 2, and 3 that is already provided. I'm using this. So that is I had put it in the this one is the read Excel file. So I have used data frame. I had created one data frame. So this one is pd.read underscore Excel Kruskal-Wallis.xls file. And then this is the output is reflected here, right? That is the DF, right? Data frame we have opened. So from scipy.stats import Kruskal, I had called this library. And this one is the Kruskal, this function we are going to use. Data frame, this one is the DF training one. I mean, these 3 things are required, right? Training 1, sales 1, training 2, sales 2, training 3, sales 3. So all those things we have taken into consideration. Training 1, data frame sales 1, then training 2, sales 2, then training 3, then sales 3. So whether we would like to check, we had provided 3 different training programs, right, to different kind of employees. So which training program is most effective and which training program is least effective? So once we have run this Kruskal-Wallis test, now you can see p-value, it is e to the power minus 21. It's very, very less, right, as compared to 0.05. So when we want to, because if and else loop we have run over here. So if this is the final result, training 1, 2, 3 are not equally effective. Why? Because p-value that is less than 0.05, on the basis of which, so we have created, if the p-value is greater than 0.05, then that would print training 1, 2, 3 are equally effective. Means null hypothesis would be accepted. But when p-value is less than 0.05, then this one is training 1, 2, 3 are not equally effective. So means there is a difference. Means training are varying, and that is why output is varying. So I hope you understand where we are going to apply Kruskal-Wallis test and what could be the coding in the Python, how we have to run this Kruskal-Wallis test. So I hope this video would be helpful. Stay tuned and keep watching.